My name is Matthew Wailicki. I'm a fourth-year graduate student in geochemistry, working with Mark Harrison. I look at what are called impactites. They are lots of different types of rocks that crystallize in impact events. And I specifically look at one grain within the rock, which is the zircon, which is ZrSiO4. A typical day for me would be, if I have samples that I'm currently working on, would be crushing the rocks. I have to break apart the rocks so that I can separate the right grains. And after a few steps, we can get to isolating merely the zircon grain, which is what I'm interested in. Then I would mount these grains onto a 1-inch round disc, and eventually, after some imaging and some polishing, I would put them into what is our ion mass spectrometer, ion probe. The ion probe is a mass spectrometer, so it is separating certain elements by their mass. The way we do that is we shoot an ion beam, which is a beam of oxygen or cesium atoms at a sample. When that impacts the sample, it will actually remove some of the sample, and that will go through a very large mass spectrometer, and the masses will start to separate as it goes around a magnet, so that things that are heavier mass will not bend as much as things that are light mass. The focused ion beam allows us to hit very small individual grains, and gives us a lot of spatial resolution. So I can probe individual zircon grains as opposed to having to get an idea of like a bulk rock analysis. And that just gives us much more freedom to identify different things and make a story of a history of what happened to the rock, as opposed to more broad-based general ideas. We can really get a specific history and look at individual grains, individual time periods, and really put together a history of a rock. I guess my main question would be, what was the impact flux on the Earth, or the impact rate on the Earth for the first billion years of the Earth's history? And how would that have affected things like the habitability of the planet or the delivery of water to the planet? Before we can start answering and probing those questions, we really need to have a better idea of what was the rate of impacts on the early Earth. How often were they occurring? How big were they? How much energy was coming in? What types of materials were being delivered? So there's a lot of first order questions that we still don't have a handle on before we can start really going for the main goals, which would be things like evolution of life on the planet, planetary formation, delivery of water. Is water on Earth unique to the Earth because of some weird impact event? Or would we expect that without even having some of these large scale impacts? So this is really first order kind of questions to go after the bigger goal, which would be more astrobiology than just like Earth science.